Hi, I'm Tom Stephenson and welcome to Understanding Construction Drawings. I'm a professor of construction management and I want to help you learn how to read construction drawings. In this particular episode, we're going to be looking at a set of floor plans, actually a basement floor plan for a house, and we're going to go through some visual exercises so you can look at the drawings and visualize them in 3D, which is important because every time you look at a set of construction drawings, you want to kind of visualize exactly what it is that you have to build. You have to think of it that a designer has to design things and they have to visualize what they want, and they can create a 3D model. They also have to be able to describe things like measurements and details about the materials that you're going to use in a variety of ways that they might not want to have in a 3D model. Plus the fact that a lot of buildings still don't use 3D models, although that's becoming lesser of a thing and we're getting more and more 3D models to represent what we're looking at. All right, so let's get started. Let's take a look at, first of all, the plans that we're going to be looking at, and then I'm going to switch over to some close-ups in a PowerPoint slide structure that I set up so that you can better visualize things. Let's go. Okay, so this is the set of drawings that we're going to be looking at. Maybe I'll just put it into a double page view so that you can just sort of get a high level view of what we're looking at. So don't worry if you can't read things. We'll get into close-ups that you can read things soon enough. So we have construction notes. These are all the details about the particular drawings that you're looking at. They may be on the first page of their drawings, they may be on the last page of their drawings, or digital copy, whichever way you have it, printed or digital. And they have a lot of detailed information that you actually don't want to put on things like the floor plans over here. You want the floor plans to be readable. You want to have basically extension lines and dimension lines that you can size things out on. And we basically start out with the basement plan in these particular drawings. So pretty much in this set of drawings, they go with the floor plans, basement floor plan, and then you got first floor plan, second floor plan. Then you go with the elevation. So this is giving you an idea of the house, the front elevation of the house over here. You'll notice the rear elevation here. Notice the step footings. We'll come back to that later on when we see that in our actual 3D representation. And we have our right side view over here and our left side view over here. Now very often too, it'll say north elevation, south elevation, east elevation, west elevation, and that's orientation based on compass direction. But because these particular drawings that were drawn for tribute by Cassidy and Company a number of years ago, on different streets, they could be facing different directions because the same house is used a few times in the subdivision, interlaced with other types of design. So that happens typically when you're building production homes, not so much when it's a custom home. Usually it'd be north, south, east, west. All right, and a roof plan. So another plan view. Remember, a plan view, this is lesson 6. So if you haven't already looked at the series, please click subscribe, click notifications. You'll see new ones that come up. Plus, if you look at my playlist, you'll find a whole array of different topics in construction, construction management, and in this series, Understanding Construction Drawings, you can review the previous videos as well. Look in the description. I usually leave links there. So here we've got another orthographic view, which is a straight cut through of the entire building. So we can actually see inside the basement. See, we're talking about the basement on this particular set of drawings. We can see footings down here. We'll be looking at those in a moment. And this is cut through, and it's called section AA, and it's cut through the floor plans. So you can see where it says AA. That's where the cut through actually takes place in the building. And so in our basement view, we can see this cut through here. And so that's what we were just looking at, information like you're looking right inside the building, like you opened it up and now you've got x-ray vision, so to speak, so you can see right through it. And the direction those arrows are pointing are the direction you're looking at. When you actually go back, and I'll just slide down here quickly, and you're looking at this, that's exactly what you're looking at. So you can see the staircases from floor to floor. You can see the column that's supporting a steel beam and the footing underneath it. You'll get an idea what these are later on, or very shortly as we get into it. Now these drawings are drawn in metric. Your drawings likely will be an imperial if it's a residential house. But no matter, it won't affect us for how we read drawings in this particular series. I can always give comparisons to Imperial, and everything is pretty much similar in other ways. All right, so let's go now to the PowerPoint slides that I can sort of show you floor plans and 3D representations of the basement plan on these drawings. So let's move ahead. This is the basement plan that you're familiar with in the previous quick overview of the drawings. Now you should be able to see it a little bit more clearly. So you got extension lines, dimension lines showing basically the width of the house and the overall length of the house. You always have to look, where is it coming from and where is it going to. You can see here where it says 200, that would be representing an 8-inch foundation wall. All right, so that'd be representation of an 8-inch foundation wall. And we can see a bunch of information here. Remember these little hexagon symbols? Well, those we could refer to in the construction notes, and that would give us a bunch of information about the foundation walls, the footings, the footing sizes, all of that kind of information. We would just refer to these hexagons and then refer to the construction notes, and it would give us detailed information on those points. So you're always looking for, how is the designer referencing things? This is fairly common, but you may have different ways that designers might reference it, but usually there'll be some sort of numbering system that you look at and it points at something, and then you can go look at it. So in a table form or something similar to that nature. So as we're looking at this straight plan view, it's sort of like, well, what are we actually looking at if we strip away all these lines as far as the foundation walls and the footings go? So let's get a little clarity on that. So we're kind of looking at this. So I've just overlaid this 3D image of a 3D model for this particular house. And so you can see that outside, and it's kind of in a perspective view, it's not an orthographic, so that's why you can sort of see a little bit down some of the walls, and you see some shadow lines here. And you can see this little cutout here, which we'll talk about in a little while. This is for the sunken laundry area. We also see a column footing here, a column footing here, sort of like a teed out column footing over here. And so if we actually take a look back at our drawings, we can see that we have this hidden line around here, and that hidden line represents a column footing. There is a steel beam that is situated over top that is going from this beam pocket. If you looked up number 16, it would say beam pocket, and it's sliding along. It's going over a steel column, and that's supported on this footing, and the footing has to distribute that concentrated load over a wider area so that the building doesn't sag. So it's designed so that the footing is big enough, deep enough, wide enough to be able to support the weight of not only this floor that's up above. These lines here represent the direction of the floor joist. So basically your floor joists are sitting on top of this steel beam, as are these floor joists sitting on top of this steel beam. And so whatever this beam is spanning, this distance from here to here, that weight comes down on the steel, and half of that weight is going towards this direction, the other half is going towards this direction. Not only that, this beam, because the way these drawings are, and we'll look at it in a future video, it's supporting a bearing wall from the second floor. So it's not only supporting the first floor, it's supporting the weight of the wall from the first to the second floor, and then the weight of that section of floor on the second floor. And so it has to be designed to carry all of that weight, both the live loads and the dead loads. The live loads are when people are walking on it, things are moving around. Snow loads, in this particular case, because it has roof trusses, it's not really supporting the weight of the roof, only the outside walls are, but live loads can be. People, furniture that can be moved around, the weight of snow when it builds up and then it melts. And dead loads are the weight of the structure itself, the walls, the drywall, the roof shingles, all of those things that are attached and part of the building. It has to be able to carry both of those loads. And so it's designed for that. So of course the steel beam is running through, and I know it's a steel beam because it says it's a W200 by 27. If you're working with Imperial, it might say a W8 by, I don't know, 15. That just means the W means wide flange I-beam, which is a typical construction I-beam. It's 8 inches high or 200 millimeters. Depends how your beams are being made, out of Imperial or metric measurement. They're slightly different. And the weight. This is the weight per meter, 27 kilograms per meter, or if it's imperial, it would be pounds per foot. The heavier the beam, the stronger the beam. So if I had a W200 that was more than 27, it would typically be stronger. If I had it less, it would be less strong, able to span a lesser distance to support the weight up above. You could easily find out what the beam weighs if you know how long it is, and then you multiply it by that number, and then you have an idea how much it actually weighs if you're trying to figure out how to move it into place, etc. All right, so we can see all of this information here, and we get a good idea again looking at this and seeing these. Oh, by the way, this right here is going to be a bearing wall. So if I look, you see the dashed line here? Well, there's going to be a 2x4 wall on top of that that's going to carry the weight of the floor joists above. When you're in a basement foundation and it shows the floor joist, it's for the floor joist of the first floor. When you're on the first floor floor plan, it shows the joist size for the second floor. When you're on the second floor, it shows you information about the roof ceiling joists and roof rafters or roof trusses from that step. Right? So you start in the basement, it shows the first floor joist. You start on the first floor, it shows you the second floor joist, and so on. And if you ever get disoriented about that, when you're reading drawings, start in the basement. And you know, well, okay, if it's showing floor joists, it's not what I'm standing on, it's what's above me. Because typically in a basement slab, you're going to have a concrete slab floor in there. All right. So we can also sort of see some information here with the walls. This just, when you see sort of this X pattern, the way this designer has drawn it, that usually means that you've got a ceiling that's going to be at a different elevation, right? And that's because this is going to be where the garage is. This is where the front porch is. That's why it says optional cold cellar. Right now it says unexcavated, which means it'd be filled with, you know, backfill. Unexcavated, but it could be, if you paid extra, it could be dug out and it could be a cold room, and there would be a door if you paid that extra amount of money to get that. Same with this rough-in. If you pay the extra little bit of money, you would get this three-piece bathroom roughed in for you, so that later on when you finish the basement, it's already there and you don't have to break up the concrete floor. That's the idea with that. We see here we've got a staircase that's going up. It's going up the stairs, and this says up 13 risers. Way later when we look at this, or I think even in the previous video I talked about that, it actually goes 11 risers up to the landing and then 2 more risers up to the first floor for a total of 13 risers. That's just kind of how this designer does it. Others may do it slightly different. They might have shown 11 risers up to the sunken landing and just kept it that way, but it's okay. Once you get used to however the designer is doing things, then it's pretty easy to follow that way. And these, as I said, is the direction of the floor joist. So this says, this is kind of, well, let's start over here. This says 38 by 184 sprue SP number 2 at 300 on center. That would be the same as 2x8s. Spruce number 2, that's the grade of lumber that you're using. There's different grades of lumber, and you know, if you have like a number 3 grade as compared to a number 2 grade, number 2 will span further because it's got tighter knots, it's got less imperfections in it, and so it's stronger to carry the joists. And that's typical construction lumber that we use is number 2 or better. At 300 on center, that's the same as saying at 12 inches on center. So here, because of the span, they kept them at 12 inches on center. Here, they go to 16 inches on center. 400 is the same as 16 inches on center. Spacing wise anyways. So we got 2x8 spruce number 2 here at 400. This is very interesting because this is kind of unusual here. 2 38s by 184, so they're doubled here. And that's because this span is even a little bit wider than this, and they would have had to go to 2x10s if they had stuck with this. So they went with double 2x8s just to keep it the same size all the way through. More than likely your design, if you're looking at other drawings, and we'll look at that in some of our other explorations in this construction drawing series, would have had a engineered or a manufactured joist floor system. In that case, it would just be showing that the joists that it was it is an engineered joist system, and you would be looking at basically whoever the manufacturers is, their shop drawings for that, which would have an engineer stamp on it to say it was designed for this particular house. In this case, these are using dimensional lumber, so these can be taken straight from the building code. and there's tables in the building code, etc. Except for the doubling. The doubling would require an engineer's stamp because that's a little bit unusual, but these spans could be done that way. All right. So we see that that's the floor joist size. We can see the size of the concrete footing, 990 by 990 by 460, right? So you're really looking at about an 18 or 19 inch thick pad here. You're looking at almost like 3 feet by 3 foot space here. You could do the exact conversions with a calculator. 25.4 millimeters equals 1 inch. But here's your pad, here's the other pad, and here's this one here. And so that's where you can find these. In some cases, it may not say the size. It just has a number. You'd look at the number, and then on the construction notes, it'll tell you what size the footing is. Or like here, it says 870 by 870 by 410. So you gather that information from these points. Here you get another representation, a 3D sort of view of it, and you can see that where the wall is coming out. You can also see that reverse veneer here where this is cut out. That's so that the sill plate and floor joists for the sunken landing can sit in there and they'll be supported. We can see the strip footing that goes around the whole foundation, and then we see the foundation wall, that 200 millimeter or 8-inch foundation wall that goes around. This is the garage. You can just kind of see the steps that go on here for the garage. We'll talk about that in a minute. So we get a good idea there. And so with the basement footings, we'll take another little bit of a close-up look at that. Where we've got the footing, we can kind of see it a little bit clearer going around here. So this little corner here is actually where we're kind of in this direction looking that way at this, and you can kind of see the angle over here, and this part in here is where the garage is. And we'll start to look at these dashed lines here in a second, which is basically your grade beams. You can also see a cutting plane line here. Remember we talked about the cutting plane line through the whole house? This is just a little cutting plane line for the detail on these grade beams. And it gives you the information, 300 wide by 200 deep poured concrete grade beams with 4 10M bars. 10M bars is 10 millimeter rebar steel that's going in there. So if we take a quick look here, there you go. There's your grade beams going across here in that spot. And so that's what they look like, and going across, and you can see it from a different viewpoint here. You notice when you look at a different viewpoint in the model, some stuff is hidden. Like I can't even see those footings over there because this wall here is kind of in the way. Whereas when you look at a floor plan, you can always see all of the footing material here. So that's something to get used to too. What do I see on this plan, and what don't I see? That's the other thing, because you don't see depth, you don't see heights of information. That's where you got to look at an elevation drawing. So every drawing has its purpose and the type of information that you can see. So that detail B, which is also on the drawings, it's actually on the full drawings on the bottom left corner. It's a reference. Look for detail B. There's detail B. It says NTS, not to scale, so don't use a scale ruler on it, is what it's trying to say. And we've got, there's your size, and you can see it's a little bit tapered down here. It's 200 by 200 at the bottom, a little bit tapered here. 410M rebars that are situated there, and that's pretty much where you park your car. This is always kind of a tricky spot in garages, especially when they backfill this in afterwards. If they didn't excavate out the middle, then it's not so bad. It just really needs compaction all around the outside edge. But if they have, then you got to be really careful that it's been properly compacted. And these grade beams are there to kind of help prevent the slab from sagging. From that perspective, but it's always a tricky sort of design when you get into those kind of areas from that perspective. Key is to have this really well compacted in the interior part here. Now you can also see this is stepped, so that's what I was referring to. Well, you don't have a basement underneath here, so because you don't have a basement underneath there, there's no need to go down this deep, because in this particular case the rest of the house is probably about 7 feet down. And here you only need to be 4 feet or 1220 to be 4 feet below grade, below the frost line. So what they do is they step this down 4 feet, then down to wherever you've excavated. You can't just excavate straight to here. If you did, then what would happen is when you put the footing here, it would be on disturbed soil. So we want to make sure this area here is cut and stepped in so that it is on undisturbed soil. So that's that little spot in this connection point here, and that's the spot over here that we're looking at. So when I say that, that's there, and when I say this, that is here, and that's your connections, and that's where your footing is stepped. Now you would see the steps on the elevation drawings like I showed you at the very beginning of this particular video, so that would be a little bit clearer that way from that perspective. So again, that's your grade beam, another view of clearly seeing the steps, and now we're putting in some of the steel beams that I was mentioning. So the footings are underneath here that we just talked about, and underneath here, remember that teed one, remember that strip footing here for the wall, and so you need to have that in place so that you can then put your wide flange I-beams across, and they're dropped into pockets so that it's actually sitting on the concrete walls, foundation walls. The builder in this particular case, it shows wood and it says that on the drawings, but it was much easier to keep it with steel, so they kept it with steel on both. And here you have a garage slab that's then poured over that grade beam that we were just talking about. And here's a porch slab that is poured over that opening. In this particular case, they don't have a doorway put in, but remember that was an option that they could have done if they had wanted to. And so we have, there is your steel beams again that I'm talking to or referring to. Here is your length of wall. Here, there's that footing that would be underneath to carry that support of that wide flange I-beam. Here's the other steel beam, and here's the other steel beam over here. So again, you got that steel beam, this steel beam, that steel beam going across. You got this footing, that footing, that footing, and then this strip footing for that particular wall to sit on. So you're starting to get the idea of what's going on here. And if you want, freeze it and take a good look at this, and then just go back a little bit and take a look at what's going on. Sometimes you need a few minutes to really absorb this kind of stuff and really think about it. And you could go back to the beginning. You know how I scrolled through the different floor plans and that, and you could take a look at that as well. That will be helpful for you to sort of visualize things. You got to take your time with a set of drawings. I tell people, you know, everybody throws drawings in front of my face and they think I know everything right away. It takes me hours to really figure out a set of drawings. And if it's like a commercial building or a condominium or something like that, it takes literally days to really figure things out. And then when you start into the drawings, you may have seen site supers and project managers that seem like they're magicians with the drawings. Yeah, but they've been looking at them for weeks. And they know how to read drawings, and they've been looking at them for weeks. So they do have a good understanding of what they're actually looking at. So here we can see these joists. They're cantilevered out of the wall, so that's cantilevered. So are these joists out cantilevered. So you get a good idea of how the joists are placed. Here there's a built up wood joist, and that's to support a point load from up above. And in the previous video I went through sort of the point load aspect, where you have a load coming up from above and it has to be transferred, either if you're lucky enough that it's right over a steel beam, just directly down, or if not, you might have to put a beam in so that you can transfer those loads around. So if you look at the previous videos, you'll see that, or you'll also see it in some of the upcoming videos when I move floor to floor on this. But definitely you can see this is now sunken over here. So this is basically lower than this. This goes up 2 risers with that stairs. And that's why I said 13 risers all the way up to the first floor, 11 up to the sunken part. And this is that porch slab, which if you remember had sort of an X on the drawings here. That's because it's not on exactly the same level as the floor. The floor is going to be 1 riser higher. And that's where that comes into play, when you have that kind of change and adjustment going on. And you can see the steps that are coming into the side over here. So you're getting a good visual of things. And you can also see the window locations. There's one over here as well. So you see 1, 2, and 3 windows. We'll talk about the L1. That stands for lintel. In this particular case, we've got a steel lintel that goes on. We've got a unique framing detail that comes here because the first floor is pretty close to grade, and the builder wanted to avoid having window wells. In this example, we'll do other ones with window wells, but there's a unique framing detail that they used on that. And we'll look at that in a future video as well. So hopefully that's getting you a pretty good idea of what we're looking at. And just to rotate it a little bit and give you another sort of view of it, here you can see the cantilever joists. And the cantilever joists, they say, DJ, that stands for double joist, TJ, triple joist, right? That's going outward. And they have to, by building code, if you're just using Part 9 in Canada, go back at least 6 times that distance that they go out, or they have to be engineered specifically for that purpose. And so it's carrying an engineer's stamp on it, in that structural engineer stamp on it in that case. And so again, these ones are cantilevered. They're going way back out the front, and you can see that how that's actually playing out there. And this one back here would be tripled, as I mentioned. So hopefully that's given you a pretty good idea of things. Here's that close-up of that sunken laundry area here with basically the framing detail. And if you remember how that had to have that cutout in the concrete, that reverse veneer had to be placed in the concrete so that you could place those joists in there, and that's that little cutout here. There's also some information here where you would have to put 320 rebars, because this area here is considered laterally unsupported. That means there's only a stairs there. The rest of the first floor is supported by the sill plate and the joist. Sill plate's anchored there with anchor bolts. The joists go on top, the plywood. It's holding the whole foundation wall really solid, but this section is unsupported because it's just got a stairs beside it. So, and you've got the weight of the backfill over here and the concrete slab, and so they put in some rebar here, 320. So 20 millimeter rebar, that's the diameter, at 100 on center, and they're near the top with 25 concrete cover. That's how much concrete has to cover the rebar, and the rebar is placed where the force is coming in. So the force is, let's see if I can get this here. So the force is coming this way against the wall, and so that's going to put those rebar under tension, because that's where steel has its strength. Concrete does not have much strength when it comes to tension. That's the weakness of concrete. Great compressive strength, very little tensile strength, but steel, huge tensile strength, and that's how both materials work really well together. And so that's what I wanted to cover today. And so hopefully you'll subscribe to my YouTube channel, check out the playlist, click notifications, and follow up on this series. If you want, go back to video 1. I'll put them in the description. Also, just go to the playlist under Understanding Construction Drawing. You'll see them listed, and you can follow along that way. Hopefully this will help you in your careers and how to better read drawings. I'm Tom Stephenson, wishing you a wonderful day, and we'll see you next time. Bye for now.